Structural Analysis 2, Chapter 12, Portal Method. Let's solve an example in a two-story frame. So if we want to determine all the reactions in the beams and columns for this two-story frame, first of all, let's determine all the center for the two fixed members, either vertical or horizontal. So if we replace a internal hinge for all of those two fixed members, either horizontal or vertical members, because as you can see here, it's a fixed one. This is also fixed, and also the same story applies for the beam one. So this is fixed, this is the center one. And in this case, we can consider or separate this part like a no moment. There is no moment at the m equal to 0 at the location of the internal hinge. So we can simply call this part and take this part out and analyze it. Then we are starting from the top of the structure to analyze and just move downward to get all the reaction in terms of horizontal force, vertical force, and also the moments. So for example, if we cut the structure halfway through from the top, from the root, we have a 20 kilonewton horizontal force applied to the structure. So, and also this is the top part and this is the overall part. So for the overall part, there is the 20 plus 30, which 20 applies to the first story. If you want to consider the lower level, you have to add up the upper level to the lower one. So that's 20 plus 30, which is making a total of 50 kilonewton apply the two-story building here, as the problem statement says. So as we know, the horizontal force is going to evenly distributed between the supports, but in portal method, the share of the central part is twice of the corners. So if this is a horizontal V, again the side is horizontal V, this is a horizontal of 2V. And likewise, we have a vertical member as well, which we have to calculate them. But pattern of distribution of the horizontal one is V at the sides and twice of that vertical for horizontal force in shearing force at the center. So the same pattern apply to lower part, which is we call that V prime, 2V prime, and prime at the first flow. So if we want to calculate make a summation of forces in x goes 0, it just gives us these 20 should be cancelled out by 4 of these shear forces. So it makes it 0 and it just gives us V is equal to 5 kilonewton. So the center one is going to be 10 kilonewton and again 5 kilonewton. The same story, summation of forces in x for the lower part goes 0. It just says this time 20 plus 30 minus 4v prime goes to 0. V prime is equal to 12.5. This is 25 and again 12.5 at the sides and 25 at the center. That's how we can get the shear distribution between the two-story building. Then next step is let's jump to our cross section and analyze, for example, this part, then 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 this part. And as soon as we have that one, we can compile all the result and then we have all the reactions in terms of either moment, internal moment, a force in x direction or y direction. Let's cut our structure by at its center and take it out so we don't have any moment because they are internal hinge. based off portal method. So we already know this is 5 from the shear distribution for the top section. So if this is 20, this is 5, Rx is simply 15 due to balance situation, and by a simple moment in summation of moment about point O goes 0, it just gives us a negative 20 times 2.5, and the only unknown is Ry. It just gives us what Ry is, and then what Oy is summation of all forces in that part of our structure. So then next move to this second part. So if you consider H, we can translate all the forces we calculated from the previous part, but don't forget to flip-flop the forces. So if on the previous section, I mean, if this is H, this is O. If in this part the forces was like this one, when you apply to the other one, it's just a downward and inward. So to be a balance between the two sections of, because it's a unified section, we just got it through. So be careful to flip-flop the forces, not the numeric value, but just the direction. As soon as you have that one, you can also have the, so this is 10 based off what we calculated here, 2 times 5 kilonewton from the distribution of horizontal forces, shear forces. So if this is 15, this is 10, it simply gives us Sx is equal to 5 kilonewton, and summation of moment about point P gives us Sy is equal to the numeric value of, again, 3.125 kilonewtons. If we move on to the next piece, like this time, after having this one, let's come to this part and see what's happening on this joint. So as soon as we are in B part, so we can have it like we already translate these forces from the bottom part. We already know V prime at here, V prime is 12.5. We already calculate this one from the shear distribution. The sides are 12.5 and the middle one is 25. We already, as soon as we have 30 here, 25 here, 5 here, so this component is going to be 25, and in a push to M, and summation of moment about M goes 0, summation of moment about M goes 0, it just gives us a Jy is a negative 15.625 kilonewtons. As soon as, so far we have this part, we have this part, this part. Let's move to intersection of E. As soon as we replace all the forces, we already know this is 2V prime 25. These are just translated from the previous part. These are, and we have a P of, at P we have like 10 kilonewtons, and Nx is simply 7.5. If we just make a summation about for example, point K this time, it just gives us Ny, vertical component of Y is 12.5 kilonewtons. And then we just come to this part like A. In J we have 12.5, the same. Ax is like all this force should be cancelled out by the horizontal component of support A. Ay we already calculated that one. That's exactly like 15J, because there is no other 15.625. And there is a moment at A, which is this couple make a moment, and MA, it just gives us a negative 37.5 kilonewton times meter times meter. So it should be kilonewton times meter. That's a moment, and the direction negative says the direction is the opposite. So this is our MA direction. This is our MA direction, which is a 37.5 kilonewton meters. Let's go, for example, for the second other one, like what happens in B. This is like 25, and it makes it Bx is equal to 25, By is 0, and just makes it like 75 kilonewton. 3 times 25 make it 75 kilonewton. And if you want, for example, you can represent the moment distribution for any part. For example, in our case, we just draw the moment distribution pattern for the medial horizontal beams, and but you can drive it for any other part as soon as you have all the reaction in terms of x component, y component, and moment. Thank you. We solve more.